Hey everybody, how's it going? We here today are representing Pymetrics. So a little bit of background about us. We are both psychologists of a different flavor. So my colleague Michelle has spent over a decade working on the client side and now on the vendor side on how exactly you measure human beings for workforce capacities. I am a psychologist turned computer scientist, and to summarize my background, I basically went from trying to understand the human mind through the human brain to building models to understanding the human brain to building models to understand the models that I was building to understand the human brain, which is how we get here. So Pymetrics, if you're not familiar with us, is a one-stop shop for all of your workplace assessment functions. So we do job analyses, we do workplace assessments, we do interviews. And above all of this, we do this fairly and accurately using artificial intelligence that is audited to the legal standards wherever we are live. And to give you a flavor on why this is important and how we do this, I think it's worthwhile to start on, I guess, the ground level of how a data scientist might go about solving this problem. So say that you're tasked with evaluating applicants to a particular system. You have a stack of resumes, and you need to figure out how to filter through them. Well, you as a person, you either have a reference resume. This can be a physical resume, or it can be one that's in your head of the ideal candidate. And what you do is you manually go through and you figure out the things that you want. You're trying to identify keywords. You're trying to identify benchmarks, how many years of experience someone has. Unfortunately, because you don't have a whole lot to go off of, you also might be making decisions off of things like formatting, whether or not someone's using Times New Roman or not. And at the end of the day, as a human being, you're going to be using flawed intuitions in order to be making decisions on an important criterion such as, should this person work at my company? So you say, okay, fine, I can't do this at scale, so I'm going to have a data scientist create a machine learning algorithm to do it for me. And what this machine learning algorithm is going to do is it's going to take all of the material that you have, a big old stack of your desired employees, and a stack of people that either didn't make it in the company previously or were identified by a recruiter as being just not a good fit for this role. The algorithm will then go through and, to some degree of explainability, pick out bits and pieces of things that it thinks matter or do not matter for the system, eventually highlighting on a series of rules that can be used to make a decision about a candidate. And over time, this AI is going to learn features that a human being might not even have been aware of. So in this very real case study that was done by Vivian Ming, if you look at an algorithm and really peel this apart, you sort of get the headlines that have been in the New York Times recently, where you can find very real facts, where, for instance, if you're screening an engineer, you can identify that if they list C and C++ as two separate programming languages versus someone who says C/C++, thereby implicitly saying that those are kind of the same thing, ask one of your engineers, they're very much not, you will identify a very real criterion that is looking at latent knowledge underneath. However, if you dig a little bit deeper, you're like, okay, well, some of the engineers that we want to hire, they seem to come from very prestigious universities, and they might have an extracurricular in a sport. Great. Let's look at the people we want to avoid. Well, it looks like this person's coming from a historically female university and a notoriously all-female sport. So you'll find when you crack into this and you actually look into it, the actual engineers that you put into the stack of people to hire were 87% male, and the people you put into the stack of engineers to avoid were majority female. And this is exactly how societal bias gets propagated. So we have this promise of AI, where we're going to take a very manual process that is slow, error-prone, and historically biased. I can show you literally dozens of empirical studies showing that resume review is biased and ineffective. Now, at the same time, AI is supposed to take this process, it's supposed to make it scalable, targeted, and blind to societal bias. Now, The unfortunate issue is that we did indeed make something scalable, but we made it scalable with reinforcing this error and reinforcing this bias that previously existed in the world. And so we here at Pymetrics take this as a very serious thing that we want to remove from society. And to give you 4 steps on how this is done, step 0 is simply don't panic. There's a very real learning that is to come from this. Algorithms are learning from real-world data, as our colleagues from Facebook just discussed at length. But if something is making a decision on real-world data, this is uncovering a real-world problem. Algorithms are not creating new problems, it's putting very real problems right in our face. So, we can teach an algorithm to account for systemic bias, and we can in turn use algorithms to make the world a better place. That is our mission, that's what we're trying to do here. So to give you a couple of examples on how we do this, first and foremost, you need to get valid measures. So at Pymetrics, what we do is we use psychometric evaluations that have been empirically validated and studied at length. If you understand a priori that there should be no reason why men versus women should have a difference in your workplace, then you need to get a measure that shows there's no difference between the two. So for us, cognitive traits, they are multidimensional, and they give you a fingerprint of who someone is. You can actually get into a meaningful difference that can distinguish between populations in different senses. To give you a very quick example of some of the things that we do, if you look down here at the bottom left-hand corner, that olive dot, those are data scientists, my people. You tend to find that data scientists tend to be rather less risk-taking than the average, and they tend to learn quite a bit from immediate feedback. On the opposite side of the spectrum, in the far upper left-hand corner, that pink dot, those are people who are buyers in the fashion industry. You tend to find that those people tend to be very risk-taking and tend not to listen when people criticize them, which are things that are very beneficial in the fashion industry. These are data-driven things. This isn't something I sat down and just figured out. This is something that the data told us by the way that people behave. The second step that you need to do is you need to collect representative data. No matter what you're doing, you can't just ignore it. You cannot just put your fingers in your ear and not collect data on someone's gender, someone's ethnicity, or other protected status. You need to actively collect it, and you need to look for differences. So here, if I were to ask you if there's a difference between men and women, it's relatively hard to say. However, if you aggregate more and more and more data, you start to see trends that you would not have seen if you had a very shallow pool. And now we see that there are more women far to the right side of this distribution. So to identify if your algorithm is biased, frankly, and I can't believe I have to tell people this, you need to measure the things that are important. So, at Pymetrics, we get all of this voluntarily. You get all of this through various channels, but people want to help you make society better. People will voluntarily give you this information. Step 3, you need to build for fairness. So just like you can train models to, over time, be more and more and more accurate, you can define the loss function for an algorithm to be less and less biased, more and more fair. So this is a very real output of a model that my data scientists completed last week for a client. So over time, what you're seeing is over various training iterations across our algorithm, our instrumental measure of fairness improves over time. You're normally used to seeing this as a data scientist to seeing your accuracy go up. You can use this to see fairness improve. Over time, over 20 iterations, only 20 iterations, we're getting to a point where you're seeing 95% parity across all 8 protected classes that we measure. Lastly, you need to audit your algorithms. So our colleagues over at MDS gave you a great overview of some of the things that you can do. The colleague after me is going to be speaking quite a bit about how they can do it. It's a very easy thing in this day and age to find someone who can help you with this. So if you have a linear model such as this, you can tell very easily what's going on behind the scenes and how it's making its decisions. And even if you have the most complicated type of model out there, such as a fully connected neural network like this, otherwise known as a black box, you can still check to see if the decisions being made by the algorithm are biased. And if you want help doing that, we open source our code for how you do that. We call it Audit AI. It's still new. Forgive us if there's a couple of kinks to work out. But it can show you all of the things that you need to do to check for regulations within the United States and across the globe. And lastly, we're firm believers in the initiatives being done by countries across the world to look into this, to ask these questions, and to ask, is an AI explainable, transparent, and fair? And is it actually benefiting the human beings it was made to do? So following this, we're going to have just a brief conversation on the actual ethics of what's going in here.
Thanks, Lewis. So there's been a bit of discussion from some of the prior speakers around, ethical frameworks and the considerations around ethics. And what I wanted to do now was really just share some of our own considerations around how our, technology and platform can actually be used with ethical considerations in mind. So the first point is around think through the possibilities. So one of the things that we do is we think through the different ways that clients could potentially use our platform and our technology, and also some of the ethical implications of that might come up. And so we provide them with proactive guidance around the best way to use us, the best use cases, and the things that they need to think about to mitigate potentially some ethical considerations. We will also be very open and upfront with our clients when we're having conversations, and they might be suggesting a use of us that may not be as ethical as we would like, or may raise some ethical concerns that they simply may not be aware of. So being on the forefront and being proactive in that regard is absolutely crucial. The other aspect is around, can we actually proactively do more? So we've heard a lot this week, and the Prime Minister talked about this at length earlier in the week, around the implications for automation on the jobs that people are doing today, and the impact for ongoing employment of our society. And so for us, we've thought long and hard around how can we actually help our clients through our technology to be able to address some of those concerns right up front. So we have things such as technology such as a marketplace, where candidates who might be unsuccessful for a role with one of our clients could actually find opportunities with our other clients in terms of being matched to their recruitment models. We also have a number of different internal mobility initiatives, so being able to support clients to look at how they can actually move people internally and then reskill them should they have some skills gaps, rather than I guess passing on them and having them exit the organisation and having to fend for themselves. And the other thing that we do is we work with organisations such as the Dandelion program, which is focused on supporting people with autism and helping them to find very meaningful and relevant work that they're going to be satisfied in, and contributing very positively to society as well. And we've been able to build some algorithms to predict success in those sorts of roles and those sorts of opportunities. And so the last point that I wanted to make that stems off that is around seeking diverse views. So we've talked a lot about ensuring that your data sets are representative, but what might be perceived to be ethical for one person may actually not be perceived to be ethical for someone else. And so having that diversity of thought and working actively with clients is one of the things that we really foster. And Lewis is from our New York office. He's been spending the week with us here in Singapore. I'm from the Melbourne office. We have an APAC team, and we're constantly in conversation around how can we ensure that our technology is representative of all of the people who we support and service. So just the last slide. Perfect. So just to finalise, our real mission is to help everyone find their place in the world of work that is fair and predictive. It sits at the cornerstone of everything that we do, and matching talent to opportunity, predictive and bias-free is our catchphrase. So thank you for your attention today.